everyone, welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your CBNST class. This has been classes is your computer-based numerical and statistical techniques. This has been class 3rd here, where we had completed your class 2 in the last classes. In this we have started with unit 1 here in that is in the last 2 classes we had started with, even though, and that has been the unit 1, and the name of the unit is your computer arithmetic errors and rules of equations here, which we have to discuss as well. So other than this, we had done many of the questions related to it, and even though we had done many of the topics related to it in the last classes, but here we have to continue for moreover next questions that has been asked in this particular manner, and of unit 1 here, that has been the computer arithmetic errors and rules of equation. Before starting with this, it's a huge request to all the viewers to please go to with the subscribe button and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even you can also enjoy the video as well. We'll go ahead for the question here. The question has been arise here: explain rounding errors or round off errors. Rounding errors or round off errors. So here for the rounding errors or round off errors that we have to talk about it. So in that, rounding errors take place because of rounding the last significant digit to the nearest value. For example, for this, if we have your value that has been 1.6 and that has been equals to 0.16666 till infinite. So if our computer represent only 6 significant digit and after the decimal point, so then the 6th digit must be rounded, and then above value become 1 upon 6 is equals to 0.16666, and that last 6th digit after 6 is your become 7. So here you have to note that the last digit of the 7, since it is rounded off, so hence the error will be, find out error here as well. So error equals to 0.16666 till infinite minus 0.16667 here. So it will become is 0.000000333 here. That we have as will be the answer here. So following table to be illustrate the results of the truncation, which is your chopping or rounding off. So for that we'll go ahead and made a table here, so that it will be clear to you very in a easy manner. So we'll talk about that method what we'll use here. Then your true or actual value, then we have your approximate value, and of course your absolute value here as well. Okay, so coming towards it, we have your method here, which is your truncation or chopping. In same case for chopping here, that has been the time or the actual value is your 5th decimal, that has been greater than 5, will become 1 upon 6 equals to 0.1666666, and that is, it will become, this digit is made 7, since 5th decimal place is greater than 5. So for the same, it will be your 0.16666 and 6, and for this it will be 0.1666 and 7, that's 7 here. Okay, for this it is the absolute value will be 0.000000666 till infinite, and for this it is 0.0000033 till infinite here. Okay, so this is the error in truncation or chopping or rounding off that we have here. So we'll go ahead for the same. Next we'll go ahead here, that the above results that shows that rounding operation results in less absolute error that compared to the truncation. We go ahead for the next one, which is to define and explain the machine epsilon. In terms of machine epsilon here, so here for that, when the number is to be digitized, it is quantized to nearest digit level, digital level, that the number of the digital levels depends upon the numbers of binary bits. For example, if a number is represented by 3 bit, then there will be to the power 3 equals to, which is of course equals to 8 quantization level. If the value of the number varies from 0 to 8, then 5.1 will be quantized to the level 5, and its binary equivalent will be 5 whole 10, that is being 101 to it converts into the binary as well. On the same cases here, with regard of it, that you have to know that an error of 0.1 is introduced while storing the number 5.1 in the memory, and this error depends on the machine because number of bits are different depending upon the resolution of the machine. It is called machine epsilon as well. On the same cases, where we go ahead for the next here, you have to round the following numbers to 2 decimal places, and we'll go ahead for the same. Round the following numbers to 2 decimal places. The first for that we have here is 24.5431, and for the second number we have for this as well. We made a table here at at once here for all. The third number we have is 102.6554. So what would be the effect of truncating the above number? So here that shows the truncations of rounding of the given number. So we first discuss about the serial number, of course, that what we had mentioned here as well. Then we have your given number, what the number has been given. Then we have rounding, and of course the truncation. But this is the first number we have here, just 24.5431. For the same we go ahead, and here that third digit is less than, we have here. For this we will go ahead here. So here third digit is less than 5, hence second is 24.54 itself, because that is being less than 5 digit will remain as it is. Okay, so that is, it will be your 5 or 4 only. So we'll get your truncation is 24.54. अगर आपका लास्ट जो डिजिट, लास्ट थर्ड डिजिट जो लास्ट सेकेंड डिजिट होगा in terms of it, अगर वो 5 से कम है तो it will be the remaining the same. But if it is greater or less, then we'll solve that condition as well. That's the reason I had given you this as here right now. We'll go ahead for those conditions as well. The second condition we have, that the number we have first, which we talk about it, is your 7.4679. This has been the number. So third number we'll talk about it here, and that is being named as. For this, it is that the third digit is greater than 5, hence second is 7.47. क्योंकि ये जो है वो आपका ग्रेटर था, इसलिए इसमें ऐड ऑन हो गया, ये 6 जो है वो 7 हो गया. That digit will be rounded to higher value, so it will become as 7.46 that we have here. Okay, now we will go ahead for the next one, which we talk about it. That is seen as follows, that the another number we have here is your number is 102.6554. For that we have a number here. In that, as you can see, this number, what it will be, the third digit is equal to 5, hence second 102.66 digit will be rounded to higher value, which is 102.65 that we have. So this is a truncation and rounding of numbers here. In this table, you can see that you have observed that the numbers that are rounded to 2 decimal places, and hence we have to check the digit here, and that at a third decimal place. If third decimal digit is greater than or equals to 5, then second decimal digit is increased by 1, and if third decimal digit is less than 5, then second decimal digit is left as it is. So that is in general for rounding. We can say that if nth decimal is greater and equals to 5, then n minus 1th decimal plus 1. If nth decimal is equals to 5, sorry, is less than 5, then n minus 1th decimal is unchanged. So for truncation, 2 digits after decimal points are considered and remaining digits are simply discarded here. So we'll go ahead for the next, we talk about it, and that will be the analysis and the estimations of error here. So analysis and estimation, which is of course the important one, and that even though we have to talk about it here as of now, so we'll discuss that same as here. So in the same case, to explain the absolute error and the relative error, and we'll go ahead for the same. In terms of absolute error, and relative error. Same case for absolute error, we know that error that can be calculated as, and that the formula for error we have to find out is your error equals to true or actual value minus approximate value, where the above error is also called a true error here. Definition for the absolute error is that for absolute error, that the magnitude of a true error or error that gives absolute error here. And for the same, we will have your formula for this, which is the absolute error equals to true or actual value minus approximate value. Okay, and which is being representing like E of A equals to uh, error, and that is equals to E of T. So the absolute error that depends upon the magnitude of actual and approximate value, and hence only absolute or error does not provide complete information. Let's go ahead for the definitions of relative error. When the absolute error is normalized with respect to the actual value, then it is called a relative error. And for the relative error, we go ahead formula with true or actual value minus approximation value upon true value. For that, it is your absolute error upon true value. So here for that, percentage relative error, we'll find out for the same. So percentage relative error, if I'm going ahead, we can say that percentage relative error, which will be ER, absolute error upon true value into 100. We'll find out for the same. So how to calculate the error when true value is not known, and for that you have to calculate the error when true value is not known. So in most of the situations, true or actual value is not known, and when solutions are obtained by the numerical technique, then actual true value solutions are not known. In such situation, the relative error is to be calculated. So I just write it down the recommendation that what you have to do when you have to solve it out, this formula with this. So calculate error when true value is not known. जब true value आपको नहीं पता है, then you will use the formula relative error equals to approximation error upon approximation value. So here the approximation error that cannot be obtained by this, and by the numerical technique that work iteratively to obtain the solution, then the approximate error that can be calculated as, and for the same the approximation error we find it out here. So with the same cases we go ahead and with respect towards it. So we have your approximation. So here for the same we have your approximate error equals to current approximation minus previous approximation here. So for the same we have to find out, and that's what even though we have to talk about it now. And the relative error is then calculated as here, which we have to talk about it, and that will be the relative error, which is ER, and that is being equals to current approximation minus previous approximation upon current approximation. Now we'll go ahead for the next question. That has been of course important one here, that what we will have to talk about it. The question has been that the height of an observation tower was estimated to be 49 meter, whereas its actual height was 47 meter. You have to calculate its absolute and relative error here. So we'll go ahead for the question as well. So the height of an observation tower. So for the observation tower was estimated to be 49 meter, whereas its actual height was 47 meter. Calculate its absolute and relative error. We have to find out for the same. So we'll go ahead for the solution here. So true value equals to 47 meter, approximate value equals to 49 meter. So absolute error equals to true value minus approximation value equals to 47 minus 49 equals to 2 meter. So relative error equals to absolute error and true value. So it is here 2 upon 47, which is equals to 0.04255 and 3 that we have. Now we'll go ahead with another question that we have to talk about it, which is of course being important one, and on the same cases we have to go ahead for here, and which has been another important question that you have to calculate the absolute and the relative error in the following cases, and you have to comment on the result as well. The true value for this 1 into 10 to the power minus 6, and approximation is 0.5 into 10 to the power minus 6. So for the same we talk about it here. Question is, so for that question it will be take the longer. So we'll do another question here, which is if x equals to 0.4000 is correct to the fourth significant digit, you have to find the relative error. So we'll do this. If x equals to 0.4000 is correct to 4 significant digits, find the relative error. That we have to talk about it. So on the same cases here we go ahead and we have to find out. So we'll go ahead for the same here. So here x is correct to the fourth significant digit, and this means there will be an error in the fifth digit, and the maximum value of the error will be, so with the same we have your error equals to 0.00005. This is the 5 here, it is your maximum value, and with this is your 4 zeros for 4 correct significant digit, that after decimal point you have to note that the error cannot be 0.00009, and since it will be rounded and then error becomes 0.001, you have to note that this error represents only 3 correct significant digits. Thus the maximum absolute error is that we have here, which is being known as EA equals to mod of E equals to 0.00005 here. For hence relative error equals to absolute error upon actual value. So relative error, that absolute and actual error. So we'll put the value here 0.00005 upon 0.4000, which is equals to 0.000125. That so thus the relative error is 0.000125 if the number is correct up to 4 significant digit here. So here we're gonna end up with CBNST, which is your computer-based numerical and statistical techniques. In this, after completing this, we talk about it. Yes, this has been the unit 1 we are dealing here. Other than that, we have to done with respect towards it. Other than this CBNST, we had done your sociology and software engineering, even though we had done your chemistry, where we had done in that unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9 as well. And other than that, we had done your conversions, logarithm, antilog, element symbols, and with their atomic mass and molar masses as well. We had done understanding the human being comprehensively, the human aspiration and its fulfillment, which is where we had completed that as well. In that we had completed unit 1, unit 2, unit 3, unit 4, unit 5, unit that with their 2 marks possible question. We are dealing with ER diagrams, which has been important for you all. And after talking about that, yes, we had done your reasoning. In terms of reasoning, which we had done your verbal reasoning and non-verbal reasoning. In verbal reasoning, we had done your general mental ability and the logic reasoning. In non-verbal reasoning, we had done your series analogy, classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dides, or situation, figure formation analysis, and then we had done your practice question set as well, which has been also important for you all. In terms of it, we are dealing with the quantitative aptitude. There we had to start discussing about this has also been divided into 2 sections, which has been your the arithmetical ability and the data interpretation. In arithmetical ability, we had done operations on numbers, LCM and SCF of numbers, decimal fractions, simplifications, square roots and cube roots, and then problems on numbers, problems on ages, stars and indices, and percentage we are dealing here. In terms of computer-based numerical and statistical technique that we talk about it, we are dealing with the unit 1 here. In that we had done your computer arithmetic errors. Here we had done your floating point arithmetic, machine epsilon, and round off errors, chopping errors, truncation error, associative and distributive law in the floating point arithmetic, inherent error propagation, numerical instability as well. And roots of equation, we'll discuss about the second method, Newton's epsilon method, and a fixed point iteration methods for the simple roots and derivations of their rate of conversions, Atkinson's accelerations of conversions, modified Newton's epsilon method to the multiple and the roots and the bridge Veta methods for the polynomial, and Barstow method for the quadratic factors and computer algorithm of their methods as well. In unit 2, we'll discuss about that has been the interpolation, where we have to cover up the algorithm and the error analysis and the Lagrangian, Newton's divide and differences, interpolation, relationship in the various difference operation, piecewise linear interpolation, cubic spline interpolation, natural spline, and as well as your Chebyshev's polynomial approximations, Langkos economizations of power series, curve fitting, which has been linear and non-linear linear least squares approximation, will in the least squares methods, where grain, ascribant, proportion, orthogonalization, and computer algorithm of the least square curve fitting as well. In unit 3, which has been the differentiation and integration. In differentiation, we have to cover up the method based on the interpolation and the finite difference, which has been Richardson extrapolation, integration, errors analysis and the representation, and the trapezoidal and the Simpson method, Newton's Gates integration method, Gaussian integration methods, Gauss-Lagrange method, Rohato integration method, and the Redison integration method, error terms in the integration method as well. Unit 4 is the solution of simultaneous linear algebraic equation, where we have to cover the Gauss elimination method, third, and the conditional system, condition number, successive and over the method of the rate conversion, solutions of the ordinary differential equation with the single step method, range, that is your Rangi-Kutta second order, and the third order of the fourth order methods, that multiple step predicator and corrector method. Statistical technique, we have to do with a statistical hypothesis, test of hypothesis, type 1, type 2 errors, level of significance, and test involving the normal distribution as well. So here we're gonna end up with this a huge request to all the viewers to please go through with the subscribe button, and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even you can also enjoy the video as well. So thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.